As you already know, there's a lot of sustainable reuse and use of energy, specifically up here in the north in Sweden. We had, for example, this company H2Green Steel, now renamed, which really focuses on using especially water electricity for carbon-free, especially emission-free steel production. Sounds really good, right? We have a lot of water energy around here, and making use of that instead of just letting it drain into the sea, it's a good idea. However, recently I realized, since we began also exporting more and more of this energy, the electricity prices for end consumer increased by 3 times. Not just a few percent, but it's now 3 times higher than in the past. And now is the question, is that okay or not? And this is one of these ethical dilemmas we are having, whom to benefit and what to do in these global optimization scenarios. And if you'd like to structure them a bit, it's, for example, about resource extraction and environmental justice. In order to have this green transition, especially when we want to use AI methods, we do need more material. But how do we get that material? Or to produce green energy, we need more of the wind turbines. But we don't want to have them in our backyard. Or maybe it's okay. So the global good could be a harm for specifics, or clean energy for some, is environmental harm for others. And what to prioritize? It's a big question. And then we have AI, which can help us to reduce energy consumption. But by itself, AI requires energy. And if we do not take it into the equation, there is a kind of hidden footprint. And if the invests goes just into more and more free hardware and data centers, this hidden footprint will not be taken into account by bigger companies. The next issue is, who actually has the algorithmic control? And if we have it, we might even have a power concentration. Like if specific large tech companies or governments have access to how the power will be concentrated, they might want to prioritize themselves. The next one is about bias and inequality in smart systems. We have already inequality in current systems. And with AI methods, when we do not carefully train them, we could just enhance and multiply this bias. And more, for example, high-income people would be benefiting from the smart transition. Then there is also transparency and accountability. What happens if there is a failure? Or if we have a region which is totally underserved? These are all issues, and besides these ethical issues, there are also technological issues. For example, we can have this technological lock-in. Think about the fuel cars, and then electric cars came up. Maybe the payout of new technologies wasn't big enough yet, and this transition into new technology was halted by some companies. And we could have that again. New technology comes, and an even better alternative could arise, but people still want to have return of invests of what they have done in the past. Or if you scale up too quickly on something, while a better alternative might be already on the horizon, you might stop scaling up too quickly. And then there are these intergenerational and long-term risks. A very prominent nowadays is nuclear power. For a while it has been stopped by many countries. Nowadays countries are rethinking and using more and more nuclear power. But this long-term risk is so long that we cannot really estimate what happens in a few thousand years. And generally there is this issue of data ownership and digital sovereignty. We have sometimes urgent issues and we want to fast do something, but we have to carefully think of how to fairly distribute not only power, but also access to data, that really everyone can benefit and not just a few. So all in all, this energy transition is not only a technological challenge, but it's also a question of who controls, who benefits, and bears the risks.